While many of us may know that electric currents can produce magnetic fields, how do we calculate the magnetic field due to any configuration of current? While not extremely common on the AP Physics C, E&M exams, one formula that can come in handy is the Law of Biot-Savart. Biot-Savart's law provides a relationship between the magnetic field at any given point and the current, distance, and length, and is honestly quite complicated at first glance, so let's take a look at each component separately. In essence, this equation sums up all of the magnetic field contributions due to each tiny piece of current-carrying wire along a random string. The first thing that's vital to note is the cross product between two quantities, the infinitesimal length of wire ds and the unit distance vector r hat. The direction of the ds vector is in the same direction as the current, while r hat is simply a vector of magnitude 1 in a direction that starts at the piece of wire and ends at the point under analysis. The direction of this cross product is given by the right-hand rule, pointing your right index finger in the ds direction, right middle finger in the r hat direction, with your thumb giving the direction of that small magnetic field contribution, which we'll call dB. But Biot-Savart's law calls for the integral of all of these small cross products, multiplied by different constants and variables all combined. Because of this combination of all these infinitesimal vector dBs, we must take into consideration the direction of these vectors, as some may cancel out. However, this idea is a bit trickier to grasp without some example problems, so let's take a look at the magnetic field associated with an infinitely long piece of current-carrying wire. Let's find the magnetic field B at a point P that is a distance big R away from the wire. Examining the infinitesimal piece of wire some length up S the wire from P's level, we can easily find out our R through the Pythagorean theorem. In addition, the direction of our cross product, ds cross r hat, can be found using the right-hand rule to be into the page. Now, the good thing about this situation is that regardless of what ds we are examining, the cross product of the numerator will always point into the page. Because of this, we can directly integrate or sum up all of these dB infinitesimals with no constant or corrections in front. Using the relationship that the cross product is a scalar product times the sine of the angle between the two vectors, and noticing that the sine of our angle can also be found using basic trigonometry, we can integrate this cross product from negative infinity to positive infinity to represent the whole length of the infinite length of wire. Using trig subs or referencing an integral table which you have on your equation sheets, we can simply arrive at an equation, which if you studied Ampere's law, should look extremely familiar. In many cases, however, the direction of the dB infinitesimals will not all point in the exact same direction. In these situations, correct for these changes by applying symmetries and multiplying by necessary constants or trigonometric functions, though these questions will theoretically never show up on any AP Physics C exams. With that, you can feel good that you just finished learning about the basics of the Law of Biot-Savart.